Okay, so we're going to start by looking at section 4.3, solving linear quadratic equations. So our goal is to be able to solve a simple system consisting of a linear equation and a quadratic equation in two variables, both algebraically and graphically. So first thing I want to think about is if we have a line and we have a quadratic, so such as a parabola, we want to think about the different ways that a line and a parabola could intersect. So specifically, we're going to look, there's three graphs that could work. One showing an intersection in 1 point, one showing an intersection in 2 points, and one not showing an intersection. So one way we could have a parabola and a line intersecting at 1 point is if our line goes through and touches at our vertex. That's one way our parabola and our line could intersect at 1 point. If we want our line and a parabola to intersect at 2 points, we would have to do something like this. So it's intersecting the parabola there at 2 points. And if we wanted to not have our line and our parabola intersect, it would look something like that. So a constant linear function and a quadratic function can intersect at either 0, 1, or 2 points. So if we think the line intersects the circle at 1 point, what is the relationship between the line and the radius of the circle? Well, if we think about it, we draw our circle. If we were to draw a radius, if we want our line to intersect the circle at 1 point, what's it going to have to be? It's going to have to be perpendicular. So the line and radius would need to be perpendicular. Our second question here, does a line have to be horizontal to intersect a parabola at exactly 1 point? So no, it doesn't. It could be tangent to any point on the curve. So if I were to draw a line like this, tangent means it intersects at exactly one spot. So in this case, it does not have to be horizontal. It could just be tangent to the curve, so it could just be touching it anywhere at exactly one spot. So if we want to solve these graphically, you'll be given a line and then either a parabola or a circle, because those are the two types of quadratics we have. So to solve these, you want to solve each equation for y. So we'll get our first equation, y equals 2x minus 3. Second equation, y equals 2 times the quantity x plus 1 squared minus 6. Graph them and find the intersection points. So this would be something you could do nice and easily on your calculator. Or you could do it by hand based off of what we know about parabolas. So this one would have the vertex at -1, -6. P would be 1/2, and it should open up. You can figure it out that way as well if you didn't want to use your calculator. So we're going to try one on our own. First thing we want to do, solve each equation for y. So the first one's nice and easy. It would be 4.5 minus 3x. I'm going to write that part first. That way it's in slope-intercept form. And then our second equation is already solved for us. Now you'll notice this is the equation of a parabola. If we want to put it in standard form, we'd have to multiply both sides by 2. That way we get this equation here. So this is a parabola. We could find it out that way. Again, or you could plot this in your calculator once you know these pieces of information. So our first line here, this is going to be our parabola. So our line has an intercept at 4.5 and a slope of -3. So I'm going to kind of approximate here. Oh goodness. Somewhere around here, I think. Plot a couple points and graph it. So that's a very bad rough sketch of our line. And then our parabola, based on our equation here, we should know that it crosses at 3, 0. So I know my vertex at least is at 3, 0. And I can do a rough sketch of what it's going to look like. In this case, I drew it very poorly, but it should have 1 point of intersection, which we have coordinate 0, 4.5. Then you can check these coordinates in the original system to show that it is the exact solution. Again, you can just use your calculator. You can use either the table, if it is at an exact point, or there is a way to find the intersection of two lines. Trying a couple other ones. So our first step, we always solve for y. So y would equal -3x here. Y would equal 6 minus 3x squared here. This would be a parabola with the vertex at 0, 6. I do know that. And since this is negative, it should open down. So we can do a rough sketch. That's a very, very rough sketch. Our line has an intercept at 0, slope of -3. So we can do a rough sketch that way. Mine is a very rough sketch, very, very rough. Do this in your calculator or do it exactly. You should find the coordinates are at -1, 3. Again, mine is a very poor sketch. But those are the coordinates where it would intersect. Over here, if we solve it for y, you have to subtract the 1. This is going to be another parabola here, so its vertex should be at 3, -1. Solving this for y, we should get -y equals -x plus 6, which means that y would equal +x minus 6. So our -6 for our slope of our line here is a +1. Rough sketch of our line. Vertex here is at 3, -1. This is positive, so it should open up. You'll notice here that our lines do not intersect, so this one would in fact have no solution. So now we want to look at what this will look like if we solve these algebraically. So the first method they use is elimination. Elimination is not the method I would usually suggest, but you can follow their steps here and follow what they did to see their solution here. We will more likely be using substitution. So in this case, our first equation is already solved for y. That's perfect. So we want to substitute it into the second equation. So we have 13 is equal to 3x minus 2 times our value for y, 1/4 x minus 3 squared. So as we multiply both of our pieces times 2, 2 times 1/4 would get us to 1/2. So from here, they expanded our x minus 3 squared. So expanding that, we should get x squared minus 3x plus 9. So when we combine our terms, we'll get x squared minus 6x plus 9 inside here. So then they distributed that -1/2 to get -1/2 x squared plus 3x minus 9 over 2. So combining the 3x plus the 3x would get us 6x here. From this step, they didn't show it, but they subtracted 13. Now you'll notice we have -9 over 2 is subtracting 13. So to get a common denominator, you could turn -13 into -26 over 2 to get that piece here. So from here, what they did was they multiplied this whole equation times -2. That way, as we multiply the -1/2 and the -2, gets us our x squared coefficient to become 1. -2 times 6x would get minus 12x. -35 over 2 times -2 would become a positive 35. Now we're in luck. This factors. Two terms that multiplied get 35 and add to get -12 would be -7 and -5. So setting each of those pieces equal to 0, we should find that x is equal to +7 or x is equal to +5. So we're not quite done. Those are telling us the x coordinates of our intersections. So now we will have to plug those back in to find our values for y. So what they did was they solved this equation for y. So they divided everything by -2. Plugged in our x values of 5 and 7 to get the y values here. So that means our final coordinates will be x value 5, y value 1, x value 7, y value 4.